from cyberspace to outer space. I am pleased to bring to the stage Marco Tempest. He is the Director of Creative Technology and Innovation at ETH Zürich Space. He'll be talking about going from imagination to orbit. Now, Marco spent 8 years at NASA's Jet Propulsion Lab, and he now co-leads the Pi Innovation Hub, which is an early mission formulation pipeline that is accelerating Swiss research towards orbit. You're in for a treat. Let's give Marco a warm welcome.
Thank you. Hello, everybody. All right. So, lovely. Let me begin with a question. What happens to good ideas that don't fit neatly into existing systems of funding? Now at ETH, we have researchers doing remarkable work. AI, robotics, advanced materials, biotechnology, much of it with genuine potential for space applications. But the path from a promising concept to something that actually flies is long and fraught with uncertainty. Traditional funding works well for rigorous, methodical science. But it wasn't built for speed. It wasn't built for the kind of rapid iteration that the commercial space sector increasingly needs. Which is why we created a different approach. As you already heard, my name is Marco, and together with my co-founders, we've built the Pi Innovation Hub, named after the mathematical constant pi. The hub is our answer to the question. What we do is straightforward. We identify promising research from across ETH's departments, help transform them into focused demonstrations, rapidly prototype, and build the partnerships needed to get it tested in space. You can think of us as a fast lane for concepts that are ready to move, but don't fit neatly into existing funding structures. The key enablers are autonomy and discretionary funding. We can pivot when something isn't working, we say yes quickly, we can pursue unexpected opportunities when they arrive. So I'd like to share a few projects that have been enabled by Pi. So this first idea began with an unusual connection. One ETH department had developed AI algorithms for early bark beetle detection and forest health monitoring. They needed a way to get hyperspectral cameras over Swiss forests regularly. Another department had built a hydrogen-powered drone that can fly autonomously for up to 12 hours. We made an introduction and they're now building that aerial infrastructure. A practical way to collect data now, because high-resolution hyperspectral spacecraft are still years away. The second project is ArboSat-1, a wood composite satellite that could solve a growing environmental problem. 100,000 plus satellites are planned over the next decade. Now the problem is that when they re-enter the atmosphere, their aluminum structures release particles that may affect the ozone layer. ArboSat-1, developed together with Swiss Wood Solutions, an ETH spin-off, uses a structural grade wood composite that matches aluminum strengths but burns up cleanly on re-entry. They're now working with our Space Master students to validate the technology in orbit. ArboSat-1 launches with our partner Space Locker to the International Space Station later this year. It comprises a small module, 2 by 10 by 10 centimeters, with embedded sensors for continuous monitoring of the material. 6 months of exposure, then back to Earth for analysis. From concept to flight ready in 10 months. Alpine is a GPS receiver for spacecraft. The project comes from ETH's work on low-cost GPS technology. Now, traditional GPS for spacecraft can cost up to $100,000 and weigh up to 2 kilograms. The Alpine payload costs 1,500 euros and weighs just 63 grams. It enables dual frequency measurements of Earth's ionosphere. This is useful for space weather monitoring, tsunami detection over oceans, and precise spacecraft positioning. We have built multiple flight-ready units and are actively looking for rideshare partners to validate the technology in orbit. Alpine doesn't just reduce cost. It's about field expansion. Universities and research groups that were priced out can now participate. Bingo takes a different approach to exploration. Instead of sending a single expensive instrument like a rover, we deploy networks of many small, simple sensors that can work collectively. Each node is smaller than a golf ball. They use ultra-wideband radio for positioning, time-of-flight cameras, radar, and mesh networking. They communicate peer-to-peer and can collectively map environments where GPS doesn't work and traditional instruments might fail. The long-term target is mapping lunar lava tubes, underground structures on the moon that might harbor water ice and could shelter future habitats. First, we're testing the concept here on Earth, exploring Swiss caves, alpine glaciers, and volcanic formations. Each deployment will teach us something about how these networks behave and provides new data about our own planet. So just a few examples of our portfolio. Now let me explain how our funding structure works, because it's fundamental to what makes Pi different. We have received moderate seed funding from ETH, enough to operate through 2027. That gives us an opportunity to show that the model works. We also have philanthropic partners who want to support the function itself. Flexible funding that lets us move fast and take risks on ideas before they are safe bets. The projects we fund then graduate to conventional funding channels. ESA programs, PRODEX, industry partnerships. We are the accelerator for the initial phase, not a replacement for serious institutional investment. We are dealing with a specific niche. Projects too early for traditional funding, but too promising to let wait. This is the gap where Pi operates. Now, this kind of work doesn't happen in isolation. It requires collaboration. So I like to make an invitation. Maybe one of these projects connects to something you're working on. Maybe you know researchers or companies we should meet. Maybe you want to support this work philanthropically, or know someone else, a foundation or a family office that might. If so, we'd love to hear from you. Become part of what we're building. A platform for faster innovation. And answer the question, what happens to good ideas that don't fit neatly into existing systems? Now, we called it Pi because the number captures something about this work. It's unending, surprising, and always revealing new possibilities. What we are building is an early mission formulation platform. A way to take promising Swiss research and move it towards space faster than traditional pathways allow. Whether it stays a small experiment or becomes an integral part of a uniquely Swiss space program, that depends on its success and whether others see the value in what we're doing. What I can say is that the projects are real. The result is measurable. And Switzerland has always been known for precision and reliability. The Pi Innovation Hub is adding speed to that equation. So if that interests you, I'd welcome the conversation. Please find me afterwards or reach out to us. Thank you very much for your attention. Thank you.